Probability 13.3 exercise. First problem. An urn contains 5 red balls and 5 black balls. A ball is drawn at random, its color is noted and returned to the urn. Moreover, 2 additional balls of the color drawn are put in the urn, and then a ball is drawn at random. What is the probability that the second ball is red? So how many balls are there? 5 red balls and 5 black balls. Totally there are 10 balls. A ball is drawn at random. So a ball is drawn at random, its color is noted. We have to see what color it is and return to the urn. After having seen the color, we have to return the ball to the urn. And then 2 additional balls are of the color drawn at are put in the urn. Suppose you have drawn a black ball. 2 black colored balls are put in the urn. And then a ball is drawn at random second time. After having put 2 additional balls in the urn, we have to draw once again. And what is the probability that the second ball is red? This is the problem. Now look here, we have worked out this problem here. See, 5 black balls, 5 red balls are there. We will consider E1 drawing a black ball in the first draw. E2 drawing a red ball in the first draw. E2 drawing a red ball in the second draw. What we do is, we draw a ball. Suppose it is black in color. We note down its color. And what is the probability of drawing a black ball? 5 by 10, because there are 5 black balls and total number of balls in the urn is 10. So 5 by 10 is the probability of getting a black ball. Now what we do is, we put 2 black balls in the urn. Then what is the total number of the balls? That will be 12. And we draw a ball at random. Then what would be its probability? The number of balls has increased to 12, but the number of red balls is same, because we have added only 2 black balls. So probability of drawing a red ball is 5 by 12. Okay, that's it. Black ball has been drawn, 2 black colored balls have been put into the urn, and again the 1 ball has been drawn. The probability of getting a red ball this time is 5 by 12, because 2 balls have been added. Earlier the number was 10 and now it has become 12, but the number of red balls remains the same. Therefore, probability of drawing a red ball is 5 by 12. That's one thing. Suppose we get a red ball. Look here. See, in this case we have got a black ball, but suppose we get a red ball. Then what we will do? We will add 2 red balls. 2 red balls to the urn. Then what will be the total number of the balls? 12. What is the number of the red balls? That will be 7. So probability of drawing a red ball this time is 7 by 12. So here black, second time red. Black, second time red. Here black, second time red. Look here. Black ball has been drawn. Now this is the second time. Second time probability of drawing a red ball is 5 by 12, because number of balls there is 12, number of red balls is only 5. Now suppose we have drawn a red ball, then the probability of drawing a red ball 5 by 12, But now, after noting down its color, we have added 2 red balls. Therefore, 7 by 12. Now look here, we'll do like this. Probability of E1 intersection R2 or the probability of E1 intersection R2 or E2 intersection R2. Here, black ball, second time red ball, or red ball, second time also red ball. This is the probability. This probability we have to find out. So probability of E1 intersection R2 or E2 intersection R2. Now look here, we have written this, we have used a formula. Look, this formula we have used. We have used this formula. Probability of A union B is equal to PA plus PB if A and B are mutually exclusive. Probability of A union B is equal to PA plus PB minus PA intersection B if A and B are not mutually exclusive. But we have used this formula because these events are mutually exclusive. The probability of E1 intersection R2 or E2 intersection R2, or in place of R we have put union. Now this we have written as like this. In place of A we have got this. In place of B we have got this. So we have used this formula, second formula. See, this formula we have used. PA union B is equal to PA plus PB. Now E1 and E2 are mutually exclusive. What is E1? Drawing a black ball. What is E2? Drawing a red ball. They are mutually exclusive. Therefore, E1 intersection R2 and E2 intersection R2 also are mutually exclusive. Therefore, we have used this formula. Now, PA intersection or AE intersection R2 is PE1 into PR2. And here, probability PE2 intersection R2 is PE2 R2. And put the values PE1, PR2, PE2, PR2. All are here. Look here. PE1 is how much? 5 by 10. PR2 how much? PR2 5 by 12. That's also 5 by 12. Plus PE2 how much? 5 by 12. Look here, 5 by 12. PR2 how much? Here it is, 5 by 12. So we have put all these values. Calculate that. 5 into 5, 25. 12 tens are 120. The same thing. 12 tens are 120. 5 into 7, 35. If you add up these two, you will get 30 by 120. Sorry, 60 by 120. 60 by 120 is nothing but 1 by 2. So the probability, this probability of drawing a black ball and a red ball, or a black ball and a red ball. See, second time red ball, red ball. First time black ball, red ball. So probability of drawing a black ball and red ball, or red ball and red ball, is half. I hope you have followed the problem. Thank you.